What's up, everyone? This is LeetCode problem 70, climbing stairs. We've done this problem in Python, but now we're doing it in C++. As always, it's like this problem's like an introductory dynamic programming problem. So, right, we can read like hints, right? Reach the nth step. What could have been your previous step? Think about the step sizes, right? We're gonna read this problem. So, if you're climbing a staircase, it takes n steps to reach the top. Each time, you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So we have n steps, right? And we can either climb 1 step or 2 steps at a time. So how many distinct ways are there to get to the nth step? That's what this problem is asking. Now, I'm gonna just write this comment out just to kind of visualize what we're doing, okay? So when there's 1 step, there's only one way, right, to climb, right? We take 1 step. Now, when there's 2 steps, there's 2 ways to climb, right? We can take 1 step and 1 step to get to the second step, or we can take 2 steps. Now, when there are 3 steps, we can go up 1, then 1, then 1, or we can take 1 step and then 2 steps, or 2 steps and 1 step. Likewise, when there's 4 steps, there's 5 ways to climb, right? We can go 1 step, 1 step, 1 step, 1 step, or 2 step, 2 step, or 2 step, 1 step, 1 step, or 1 step, 1 step, 2 step, or 1 step, 2 step, 1 step. Now, let's say there's 5 steps. There's 8 ways to climb, right? We can go 1 by 1, right? Or we can go 2, 2, 1, or we can take 1 step, 2, 2, right? 2, 1, 2. You get the point, right? So you'll notice that essentially for up to n steps, this is basically what our algorithm is doing, right? This is essentially what, if we pay attention to the pattern, this is what we'll notice, right? For a given step of n, right? If we take the distinct ways from n-1 and n-2 and we add those, we get the distinct number of steps for n, right? So for example, n is 5, right? So n-1 is 4, n-2 is 3. So the distinct ways for n is equal to 4 and n is equal to 3, it's 3 and 5. So when we add 3 to 5, we get 6, 7, 8, which is the distinct ways we can climb to the top for 5 steps, right? So that's what this problem is, really, is noticing the pattern and basically using that previous knowledge to calculate the distinct ways of n. You don't want to do this problem recursively, actually, because you're gonna add a lot of overhead, and your solution's gonna be way too complicated with too much overhead. So it's not gonna be efficient. So the way we want to do this is we want to store n-1 and n-2 as we go, so we can reference it without having to like start at n and go, okay, what's n-1? And at that n-1, what's n-1 plus n-2? And then at those, what's n-1 plus n-2, right? You don't want to do it recursively like that because you add way too much overhead. So we're going to store this as we go. We're going to do it not recursively, but iteratively, okay? So the way we're going to do this is, well, first of all, let me go back. For n is equal to or less than 2, we can just return n, right? Because there's only, for n is equal to 2, there's 2 distinct ways to climb. For n equal to 1, there's 1 distinct way to climb. So we're going to say if n is less than or equal to 2, right? We're just going to return n, okay? Now, our current n, right? Our current n initially is just going to be 0. And we're going to have an n minus 1, right? And an int n minus 2. Okay? Because we know, right, we're going to start at this third step, right, for our for loop, because we already took care of these right up here. And we know at this, we're going to start at n is equal to 3. We know that at n-1, that should be equal to 2, right? And n minus 2, actually, sorry, this shouldn't be 3, it should be 1. And So when we're at this n, which is, we're going to start at this n is equal to 3, right? Because we already handled these two up here. Okay, so when we start here, which is initially where we start, n minus 1, we know it should be 2, right? N minus 2 should be 1, okay? So let's do this. We're going to say n is int I, 4 int I is equal to 3, right? Which is where we're going to start. I is less than or equal to n, because we need to include n, right? That's our input. Okay, we're going to say current n is equal to n minus 1 plus n minus 2. Okay, so now when we go up here, our n minus 1 shouldn't be, okay, we're here. Initially, this is our n minus 1. Initially, this is our n minus 2. And this is n. Now, when we're moving along the for loop, our n goes here, right? So our n minus 1 should be this, right? And our n minus 2 should be this. So we need to change these variables as well, okay? So we're going to say n minus 1, which would just be whatever the current n is. N minus 2, which is actually going to be what the previous n minus 1 is. Although n minus 1 got changed, right? So we don't actually want to put this down here. We want to put it up here. Okay? So we don't want to overwrite n minus 1 before we set n minus 2 equal to n minus 1. Okay? I mean, you could make a temporary variable, but there's no need to. Just put it up here. Okay? And then after we get that, we're going to go up to and calculate the distinct ways to climb to the top up to n. So that's what our current n is going to be. So we just return it, okay? And that's it. So this is an introductory dynamic programming problem where you're kind of storing your results and using that for later calculations. Dynamic programming is honestly one of those things that I definitely have trouble with. I think a lot of people do. So yeah, we'll encounter more problems that are obviously much harder, but this is just kind of an introduction to dynamic programming. But yeah, we're basically just storing results to use them later for a calculation. Okay, and again, we're doing this iteratively, not recursively, because we had too much overhead doing this problem recursively. So anyways, I hope this helped, and I'll see you in the next one.